Hi, fifth graders. So today we're doing problem 2.4, and this is one of my favorite problems in this book because I just kind of love reading graphs. And so what we have to do is think about the stories that are told in graphs. We did a little bit of this before we left, but let's take a look at a couple graphs. We have to answer a few questions. First of all, what are the variables in the graph? Do the values of one variable seem to depend on the values of the other? And what does the shape of the graph say about the relationship between the variables? So we have two graphs here about the number of cars in our school's parking lot during a day and how it changes during that day. So here are two possibilities. I just sent them, I made them a little bit bigger and I put them over here. So we have to describe the story each graph tells about the school parking lot, which graph shows the pattern we expect, and how could we label the graph so that we know we can tell everyone else what it's representing. All right, so this first graph, if I look at it, I say, okay, well, I'm going to use a different color. There seems to be this spike of something, and so I know it's about cars. So I'm gonna put that cars in school parking lot, right? So what could explain this spike in the middle of this day? And I'm thinking maybe there is a special lunch celebration when all parents come and they have lunch. All right. So this might be the hours of the day. Okay, and this would be the number of cars. Now let's compare that to this graph over here. Notice that this one goes up, stays steady, and then goes down. So I'd still say that we have hours of the day. But in this case, it's still number of cars, but maybe this is just a typical day. So we have a typical school day, okay? And these are just the teacher cars. So you can see the difference. Now, this hours of the day, remember that is on the x-axis. And remember that is our independent variable, right? If it was on the y-axis, it would be dependent. The number of cars depend on what's happening during the day, and in here, it's depend on what's happening in the hour of the day. All right, so let's take a look. For your question, you have to do the same kind of thing. We'll just do the first one. The number of students who go on a school trip, I'm here, is related to the price of the trip for each student. Okay, so, if the trip was super cheap, I bet a lot of students would go on the trip. But if it got really expensive, maybe not a lot of people would go. So, does anyone see a graph that would work? I'm thinking graph 2 might be a good match for that. So I might put that there. Because if the cost was like 0, yes, a lot of students would go, number of students. But if the cost was a lot, basically no one would go. So on our lab sheet, you can see part A, the independent variable would be cost. The dependent variable would be the number of students going. What does the graph tell about the relationship of variables? It says the greater the cost, the fewer students would go. I don't know. I guess that's not a great way of saying it, but it's generally what it is. All right. Give the graph a title. We could say something like school field trip prices and participation. Something like that. Participation. And in the challenge today, the bonus was to put the picture of the graph next to it. If you could do that on Seesaw, and I'm going to just show you on Notability, but if you could do that, oh, my graph didn't come. Well, we wouldn't do that. I'm going to undo that one. Undo. If you could take that picture of the graph and get it next to this part here, bonus. If you can't, don't worry about it. All right, so you have to place all 8 graphs with the situations, talk about the independent and dependent variables, and that's what I'm looking for in your assignment today. Have fun. Look forward to seeing these, and have a great weekend.